INSA has limited sensitivity to the north-south displacement due to its near-polar orbit, so standard INSA is of little use for measuring interseismic deformation near north-south striking fault systems. Sentinel-1 TOPS data provides images with two different views in burst overlap area. The increased screen angle diversity within burst overlap areas allows to achieve a better resolution of the along-track horizontal motion than conventional split beam interferometry. Orbit and topographic corrections are applied to the forward and backward-looking interferograms before generating the double difference burst overlap interferograms. The advantage of the double difference BOI observations is that they are sensitive to horizontal ground motion in the long track direction, and the influence of the troposphere is eliminated, while the ionospheric delay exists in the BOI observations. We combined the burst overlap interferometry with bars in the southern Dead Sea region. We analyzed the effect of the ionospheric delay to INSA time series, which can be ignored when working with hundreds of images. We derived the along-track BOI velocities from both descending and ascending orbits. The velocities are displayed with respect to the Sinai plate, that the far-field velocities to the west are close to zero. We average the values at the far western end of the profiles within a 10 km by 60 km window covering multi-burst overlap areas, and then subtract the average value from the result. We selected few burst overlaps from the descending orbit to analyze the displacement along the Wadi Ariba fault, the northern and the southern Gulf of Aqaba separately. As descending observations map directly the fault parallel motion, we calculated the median value of the points with the same distance to the fault within individual burst overlap and their 1 sigma uncertainties. The number of the profiles correspond to the numbers shown in previous figure A. The median value and their 1 sigma uncertainties are plotted with black dots and the gray error bars. We also stacked a few profiles over these regions and produced the average profiles with colored dots. The individual profiles show considerable scatter, while the averaged ones indicate a consistent and smooth velocity transition from the Sinai plate in the west to the Arabian plate in the east. We use the profiles from the descending orbit to estimate the locking depths of the southern Dead Sea fault based on the 1D screw dislocation model. We found that the optimal locking depths and the slip rate with lowest RMS. The uncertainties of the model parameters were then estimated by first perturbing the data set with Gaussian noise and then searching for the optimal parameters of 1000 perturbed data sets. We compared the published GPS results, which fit well with the BOI observations and the model prediction over Wadi Ariba fault and the southern Gulf of Aqaba. Well, the GPS results is limited in the north of the Gulf of Aqaba. The inverted locking depth decreased from the Wadi Ariba fault to the end of the southern end of the Gulf, which implies an increasing influence from the Red Sea Rift. In summary, we demonstrated that the applicability of the BOI time series to map the interseismic deformation across slow-moving southern Dead Sea fault. The achievable ground velocity accuracy of the BOI depends on the temporal coherence and the number of images used in BOI time series analysis. And our result reveal a fault parallel velocity of 4.5 to 5 millimeters per year, which is consistent with GPS observations. And meanwhile, it provides details of the near fault interseismic deformation.